We've been learning about scatter plots, which is one way to show data and essentially looking at some raw data that we're given and seeing what kind of patterns we see from this. This time in lessons 10 through 13, we're going to be looking at another way of looking at data. So these tend to be smaller sets of data, normally from a small survey that's taken, and this lets you kind of see the frequency at which the responses that you get. So how often people responded that they like this kind of soda or that they like this kind of ice cream or they do this sort of activity. So let's first start with just getting down some definitions. This is from lesson 10, the independent and dependent variables. And I think we've talked about this before. The independent variable is x, of course, whereas the dependent variable is y. We always get to choose numbers for x, so that's why it's independent. It doesn't really matter what x is. X can be anything. But then y changes according to x. That's why it's dependent. It changes in response to x. So that's why x is independent and y is dependent. There's also other words for this. Sometimes you see the independent variable called the explanatory variable. And you see the dependent variable called the response variable. So what these means is x will explain why y is changing. So y is changing in response to x. So you can also think of these as your cause and your effect. So in class we'll look at some examples of identifying which variable is which. The main thing I want to get to today is frequency table. So let's start with a one-way frequency table. So our one-way frequency table is essentially just a chart of our data. So let's say that I wanted to know what kind of soda students at our school likes. So I do a survey of one of my 7th grade classes. The following are the results that I got. So of one of my 7th grade classes, I asked them, hey, which of these sodas do you like? And these are the results I got. 9 like Pepsi, 11 like Coca-Cola, 6 like Sprite, and 4 like root beer. So let's go ahead and put that into this table. Well, 9 like Pepsi, so 9 will go right there. 11 like Coke, 6 like Sprite, and 4 like root beer. Then if we want the total, we of course can add this up. So this is a one-way frequency table, fairly simple, and just gives you some data, and then you can look at it and kind of see some things. So let's answer some of these questions based on this table. So the first question is, which soda do students like the most? Oh, well that's actually pretty easy for us to see, that Coke has the highest number of that students said they like. So this is going to be Coke. Second question, which soda do the least amount of students like? Well, this is pretty easy for us to see. Root beer had the lowest amount of students. Then it's asking what percentages of students prefer each kind of soda. So now we actually need to do some math. So if it's been a while since you've done percentage, you take the number divided by the total. So if I wanted Pepsi, I'm going to need to do 9 divided by 30. So grab your calculator, 9 divided by 30, and I'm getting 0.3. Now, we remember from 7th grade that that means, what 0.3 means is percentage, is 30%. So because this is 0.3, it's 30%. So 30% of the students said they like Pepsi. So let's do Coke now. So I need to do 11 divided by 30, and I get 0.366666. So we'll round that to 37%. Sprite, I need to do 6 divided by 30, which is 0.2, so that's 20%. And root beer, I need to do 4 divided by 30, and I get 0.13333, so we'll round that to 13%. And if you ever want to check that your percents are correct, you should be able to add them up, and it should be about 100. If you're getting like 99 or maybe 101, it's probably okay because we did do some rounding. So if we really wanted to check this, we could do, okay, our 30% plus our 37 plus 20 plus 13, and we're getting, oh, actually it's exactly 100% this time, so we know we accounted for everything. Now let's look at the next one. This next question says, does the chart summarize categorical data or numerical data? It's been a while since we've talked about those. Well, categorical data is talking about categories, so things that can't be put in numbers. And numerical data, well, that of course is numbers. So are we talking about things that are things, or are we talking about numbers? Well, the number of students sure is numbers, but the soda flavors isn't numbers. Those are categories. So this is categorical data. Because soda types aren't numbers. So this is categorical data. This last question says, does this data represent a random sample of all the students at our school? Why or why not? So basically, do we think this one class of 7th graders represents our whole school? Like, we would be able to go out and truly 30% of all the students at our school like Pepsi, and 13% of all the students at our school like root beer. Some of you might actually argue, yes, that, that's probably pretty good spread out amount of students liking each one. It might be representative. Some of you will actually say no, that you can't count them because those are 7th graders. They can't represent us 8th graders. And I actually think there's some truth to that. So we can maybe say that no, this can't represent all the students at our school because it's only representing one grade. So what I wrote down was it can't represent all students because it's only from one grade. Now, but if you actually really want to argue that it can, go ahead and write your reasoning. Remember, statistics is mainly about how you argue things, and if you argue correctly, you can be right. So now let's take a look at the relative frequency table for this data. So what relative frequency means is it's kind of similar to the percentages that we just found. Essentially, what percentage of these students like that kind of soda. So that's what relative frequency is, but instead of putting it into percentage form, we keep it as the decimal. So it's still going to be that number divided by the total. All right, so I wrote a lot there, but it's the proportion of students that like the kind of soda of the whole class. So you take that amount of students divided by the 30. But instead of it being the percent, we keep it in the decimal form. So you have that number divided by total. So it sounds more complicated than it really is. So we're actually going to do a relative frequency table of the data we just did. So in the table above, we said that 9 students like Pepsi. So this is the 9 of 30. Well, so what's the relative frequency of that? Well, we actually kind of already found that. That was 9 divided by 30, which was 0.3. But instead of turning it into that 30%, we're actually literally just going to leave it as 0.3. So let's do Coke. Coke was 11. So we do that 11 over 30, and that's 36. That's 0.366666. So we'll round it to 0.37. Sprite was 6, so 6 over 30, which is 0.2. And root beer, which was 4, so 4 divided by 30, and that's 0.13. So I put in the fact that the total should be 1.0, essentially 1. So this question down here is asking us why should the total be 1? Why can't it be anything else? Take a second to think about that. Why? I mean, this was 0.3, that's 0.37. Why would the total be 1? Well, if these are kind of like percentages, but just in decimal form, percentages always add up to 100%. So it kind of makes sense that the total is basically 100%, which is 1. So the total represents the whole, and a whole is 1. So the total represents the whole class, and 100% equals 1 in this case, especially considering the fact that if we added all these up, it should add to 1, just like earlier when we added all of our percents up, it should equal 100. So that's why your total box is always going to be 1. And that helps you kind of check that you did your relative frequencies correctly. So now let's take a look at a two-way table. Two-way tables let you take a look at 2 different things that's going on. So in addition to looking at how many students like a kind of soda, I can take that data a little bit further and maybe look at an additional aspect that's going on. So let's take a look at this situation. What if I want to look at more than the kind of soda that the students like? Maybe I also want to relate it to their gender. I can use it in a two-way table for this. So I'm going to use actually the same data as before. We're just going to also add in who were males, who were females. So of the 9 who liked Pepsi, 5 were girls. So there were a total of 9 people who liked Pepsi, and 5 of them were girls. 5 were female. Well, it should make sense that there's a total of 9 and 5 were girls. Well, 4 should be boys. All right, so let's put that there. Then, of the 11 who like Coke, so 11 total like Coke, 4 were girls. Oh, 4 were girls. So if there's 11 total, minus the 4 that were girls, there should be 7 boys. Then, of the 6 who like Sprite, 2 were boys. So we have 2 males, which leaves it should be 4 females. Then, of the 4 who liked root beer, 4 were boys. Well, 4 and 4, so left is there were no girls who liked root beer. So you can see that this is another really good way of looking at data because it kind of breaks it down and you can see some big outliers going on here. Like, wow, that's actually really surprising how many guys like Coke, or the fact that like no females like root beer. So this is a really good way for you to kind of spread out all the data because it's hard for you to look at it in just word form. Those numbers may not pop out to you when it's like this, but it really helps you when it's spread out into a chart. So now let's also fill in our totals. So how many males were there? Well, let's see. 4 plus 7 is 11, plus 2 more is 13, plus 4 more is 17. Then, let's see how many females there were. So 5 plus 4 is 9, plus 4 is 13, plus 0. And that should make sense because I had a class of 30. Okay? And so another way for you to tell if you did your table correctly is that your number of totals this way and your number of totals going this way should also add up. So if you're getting that this way they add up to like 30, but this way you're adding up to 28, then you did something wrong. So this is nice because it kind of checks itself. So this is what a two-way table looks like. And of course, we can figure out the relative frequency of each of these boxes. So let's take a look at that right now. So just like before what we saw with the one-way table, we of course can find the relative frequencies of these. So you're still going to take that number and divide it by the total. So whatever is in each of these boxes, you just take that divided by 30, and then that's going to be the relative frequency for specifically that box. So the amount of males who liked Pepsi, there was only 4 of them, so we're going to do 4 divided by 30, which is 0.13. Okay, so it's that simple. There were 5 females who liked Pepsi, so that's 5 of 30, so we do 5 divided by 30, and we get 0.16. For the total, we could remember that it's 9 over 30, and so we could find that out, or since it should be the total, you can just add these up. So that's going to be 0.29, okay? And you might get the same thing, you should hopefully get the same thing if we do 9 divided by 30, in which case, if I do 9 divided by 30, I get 0.3. But remember, since we're rounding these, you might get something a little bit different. So depending on how you do it, you might get something kind of different, but it's still close enough. Okay? So remember, because we're rounding, it might always change your answer a little bit. So if you put 0.29 or 0.30, it'll still kind of be okay. So now, let's take a look at Coke. So the amount of males who liked Coke was 7, so that's 7 divided by 30, and that's 0.23. Amount of females who liked Coke was 4, so we do 4 divided by 30, 0.13. Once again, we can just add these up for our total, so that'll be 0.36. Sprite, there were, 2 males who liked Sprite, so 2 divided by 30, and we get 0.066, so we're going to round that to 0.07. Females who liked Sprite, there were 4 of them. Well, we already know 4 over 30, that's 0.13. Okay, so total, we need to add these up, that's 0.20. Root beer, there were 4 males who liked root beer, so 4 divided by 30, we already know that, 0.13. There were 0 females who liked root beer. We don't need a calculator for that. 0 divided by 30 is 0. And, of course, the total should be, 0.13. So now we can just add across to get our total. So for the amount of males, we could either actually do it ourselves. We could either do the 17 over 30, or we could add them up. In this case, doing 17 over 30 might actually be easier. So 17 divided by 30, and I get 0.5666. So we're going to round that to 57. 0.57. Same thing for the females. I can either add up their frequencies, or I can just do the fact that it's 13 over 30. 13 divided by 30, and I get 0.43. Now I could add everything up to get the total, like the total of the total, but we know what this is. It always should equal 100%, which is 1. But it might be good for you to go ahead and add up your rows and your columns to make sure you're doing something correctly. So if I add all these up and I'm getting about 0.99 or 1 or 1.01, something kind of close to 1, just like before, how because we're rounding, if it's that close, it's probably fine. So now let's move on to some questions. Because now we have this table that's kind of essentially telling us the percentage or the proportion that like different sodas. So if it wasn't already telling you something beforehand that, oh, that many people like Coke or this little people like root beer, now you can definitely see based on the frequencies like, holy cow, 30% of people like Pepsi. That's a lot. But even more liked Coke, or only like 0.07 like Sprite, like of males at least. Like pretty much no guys like Sprite. So this gives you some more data. So there is a relative frequency of 0.17. What does that represent according to this data? So it's saying there's one box that has a relative frequency of 0.17. And just what does that mean in this context? So let's find that 0.17. We don't have a 0.17, we have a 0.16. So it's probably because we might have rounded a little bit differently than they wanted us to, which is totally fine. So we have 0.16 here. So this box corresponds with the females who like Pepsi. So that's what that data means. So that's the females. So that's what it means according to this data. How many females like Pepsi? It's that simple. Then it says there's a relative frequency of 0.37. What does that represent according to this data? So once again, we're looking for a 0.37. Well, I have a 0.36. So what does that mean in this? Well, that means that's the total amount of people who like Coke. Simple enough. So that's how you use your two-way table in the raw data and with the relative frequency. So let's actually look at the next page and look at one more example. We're going to take this data and we're going to put it into our two-way frequency, and then we're also going to put it into a relative frequency table. A survey was done of 30 random RVCSM students about the kind of video games they play. So of the 13 that play Xbox, 5 are 7th graders. Of the 7 who play PC, 2 are 8th graders. Of the 1 who play Wii, that 1 is a 7th grader. Of the 9 who play PlayStation, 6 are 8th graders. So the two-way data that we're doing is we're corresponding video games, the type of video games they play, essentially which kind of console, according to their grade level. So I'm actually going to let you finish this one. Take this data, throw it into this box, and then you're also going to do the relative frequency box below, and those just 2 questions at the very end. So go ahead and see if you can complete this, and then come to class if you have any questions, and you can ask me then, or you can put it in the comment section. And that is it for this lesson.